Hey, welcome to Use WisDOT Tools to Efficiently Design in Civil 3D. My name is Mitch Lavin, and I'm part of the Wisconsin DOT Methods Development Unit. At WisDOT, we use Civil 3D as our primary design tool for roadway projects. MDU is tasked with developing a Civil 3D configuration that contain a robust set of standards, tools, and workflow efficiencies to be used on WisDOT projects. This session will take a look at many of these tools and standards that are included with the WisDOT Civil 3D configuration and review how they can be used to improve workflow efficiencies in the roadway design process. First, we'll take a look at where we can get the WisDOT Civil 3D configuration. Then we will review what is actually included in the configuration. And finally, the biggest goal of this session is to review many different workflows and how we're going to use those WisDOT tools to design more efficiently. I've been with WisDOT since 2011, where I started as a design and construction engineer in the North Central region. There I used Civil 3D in design and construction. Since 2017, I've been with the Wisconsin DOT Bureau of Project Development in the Methods Development Unit, where I've been working primarily around Civil 3D and the implementation statewide. I've been working on Civil 3D training, support, standards development, and most recently standard detail drawings. So what's the process for non-WisDOT people to get the WisDOT Civil 3D customizations? It's pretty simple. They're hosted from the WisDOT website. If I go to Google and search WisDOT RDF, the first hit's going to be roadway design files, and click on Civil 3D files. And here there's general instructions for installing the WisDOT Civil 3D app, desktop app, which allows or installs the WisDOT Civil 3D customizations. So follow the instructions, download the MSI, and basically the desktop app has to be installed to be able to get the customizations for Civil 3D, whatever Civil 3D version is current. For internal staff, you should have the WisDOT Civil 3D update or update WisDOT Civil 3D icon in your taskbar here. If not, contact CAE support. On the C3D KB Civil 3D knowledge base, there is the file software management area and then the Civil 3D install and initialize process. And here we can click on the initialize, and this goes through the process on how to get the WisDOT customizations installed. Basically, we need to make sure we have the Civil 3D version WisDOT icon and the WisDOT Civil 3D apps icon on your desktop. That'll verify that you have the WisDOT Civil 3D customizations installed. So I showed how the customizations are obtained, but what is actually in it? We have a custom page on the Civil 3D knowledge base that goes over basically everything. It's the help file for all of our customizations. We have the futures, which is our Trello board, and then all of our custom items that we have, so blocks, dimension styles, layers, line types, etc. And then goes over some of the apps that we have, and then all of the different ribbon tabs that are in the WisDOT Civil 3D customizations, the survey tab, the design tab, and the sheets tab. What's nice about the Civil 3D in app, if you have any questions on any of the customizations in Civil 3D, hover over the button and hit F1, and it'll take you to the direct page listed here in the Civil 3D knowledge base for that item. Every customization or every button we have in Civil 3D has its own help file or help document on the Civil 3D knowledge base. Speaking of Civil 3D, let's jump over into a fresh file so we can jump and kind of walk through the different customizations. So I mentioned multiple tabs. We have 3 tabs: the WisDOT Survey tab, WisDOT Design, and WisDOT Sheets. Briefly, WisDOT Survey is centered on tasks and tools associated with survey processes. Same with Design, it's tasks and tools associated with design processes. And then Sheets is sheets, essentially, and annotation and plotting. Again, if you have any questions on any of these tools, just hover over them. You can click F1 to go to the help document like this. Now, many of the custom tools utilize custom CSVs to kind of be sources for how the tools are run and things that are created. One example is in the project category, the create object folders. There's a CSV that's available. We can view the default one after running the tool. A lot of the CSVs have that option, being able to view the default or view the CSV prior to running it. And it's going to open Excel and you can review the CSV. So one thing it's important to understand is there's ways that you can manipulate these CSVs, but also be able to utilize the standardized naming conventions of objects and automate a lot of processes. And that's what my main goal is today, is to kind of go through these different workflows and utilizing the CSVs to automate different things. Speaking of naming conventions, in the FDM there's a long list of naming conventions that is easily accessed here in-app in Civil 3D. If I click on any of the WisDOT tabs in the support panel, WisDOT FDM, WisDOT naming standards. And this will bring you to the attachment of naming standards for Civil 3D objects and files and such. And my best recommendation is to follow these naming standards. Our CSVs that I just mentioned on the different tools follow the naming standards set in the FDM here. And if you follow these naming standards, you should have no trouble utilizing the default CSVs, such as this. This is especially for objects like alignments and corridors and things like that, and assemblies. It's just good to follow what's listed here in the FDM. All right, let's go take a look at Civil 3D and all the tools that are available for design and efficiency. Jump over to the app. And we'll start on the WisDOT Design tab because that's going to be our primary focus for today. And I'll take a look at the first few panels on the Design tab. And we'll see the Support panel, the Manage panel, and the View panel. All three of these panels are available on all of the WisDOT tabs, just because they can be used in any of the different scenarios that we're working in. Support panel has the links to the C3DKB, the WisDOT Civil 3D Futures, and the WisDOT FDM. In the Manage panel, there's the Layer State dropdown, there's Workspace tools, there's DWG tools, there's Project tools, there's Palettes button for turning the Palettes button on and off. There's the Add Components, which are blocks, textiles, and layers tools. There's the XREF tools, which include loading an XREF on its own layer, and then assigning XREF to layer if you already have an XREF, if you want to update that XREF so that's on its own layer. We have layers tools, including the layer colors manager and some other tools. And then we have access to the layer states palette. The view panel contains the rotate view and the import views tools. But those are just kind of basics. They're available on all the palettes or all the tabs and available whenever you need them. We're here to look at design tools. So I'm going to first start with the draw panel and the lines and curves. These tools were established to fill some gaps that are in the standard Civil 3D line and curve tools. The first one is a floating line. Basically, it's going to build a line off of a curve at a distance, and it floats. So you can see I can kind of just select where I want it, and it's going to stay tangent to that curve wherever I want it to, like that. The free line is I'm going to select two curves, and it's going to give you the option of what options are available between those two curves. I'm going to select this one. This becomes useful in intersection and roundabout design. Similarly, the curves tools have a floating curve. I can build a floating curve. I can do a curve radius. I don't know what that might be. Let's try, I don't know what zoom level I'm at. There we go. And so it's building a curve that's tangent to the end of the line. And you can put it wherever you want. All right, so then we'll do one more, the free curve. We'll select the first. Now this works on arcs, circles, or lines. I'm just going to do these two lines. And You enter a radius greater than 0. Let's do 6,000. And there it gives you all the options that are available between these lines. And it does extensions. So you can see this curve here would be an extension of this line down to here. So some nice, easy design tools to make your workflow a little more efficient and making sure that your curves and lines are tangent to each other. So I've jumped forward and I created a couple of alignments and offset alignments for a temporary or theoretical roadway. And I just want to go over a couple of the first tools that kind of start with the horizontal geometry or horizontal design. My thought with this is we're going to start with horizontal, go to vertical, go to 3D, and kind of work our way through some different tools that help us along the way through those different workflows. And to start with horizontal 2D design, take a look at the design palettes panel and the WisDOT design tab, the parametric blocks drop down. And we have different palettes for different parametric blocks. We have beam guard blocks, intersection blocks, and rural driveway blocks. I'll start with the beam guard blocks, and I'm going to click on that. If the palette doesn't come up, click on off palettes here, but I've got my two palette open here. And these blocks contain the basic geometry for beam guard, rail, paving, shoulder, and earthwork for the energy absorbing terminals. And they're based on the standard detail drawings that are in the FDM. We also have the beam guard detail blocks on this palette, which are detailed objects for designing beam guards. So there's the EAT on curve, there's tri-beam transitions, and then also individual 12.5 foot rail sections, and then individual parts and pieces if you need to build your own. These are useful for establishing a geometrically accurate layout of where all your beam guard posts and blocks and spacings are going to be. So just a quick overview of what they are, and we'll just do a quick review of using them. I'm going to click on BG-EAT left tangent block, and we can rotate it to what we need it. So in this case, I'm going to rotate it about the base point here, and then I'm going to rotate it to here. And now the block is rotated to the roadway. And we want the anchor point, we're going to move it. Whatever you're doing for the beam guard install, you can put it wherever you need to. And this block is dynamic. So what I can do is put it in hide or show. The tangent one is pretty straightforward. There's not much to it, but the curve ones allow you to enter the curve radius and things like that allow you to match that curve. Now, the one downside of using these blocks, especially with the curved ones, or either of them, is if you are entering, if part of the EAT is in at the PC or the PT of a curve, they won't really fit very well because you'll have a tangent portion and a curved portion. So you'll have to do some manual adjustments if you want to use the blocks, or do offset alignments and such if the location is at a PC or a PT of a curve. The other blocks that are on here are the beam guard detail blocks, and again, these are fine-tuned details of the different parts and pieces of a beam guard installation. So I've got the MGS tri-beam transition, we've got the EAT, and then we also have the individual blocks that go in between. So I'm going to put that there, and then we can copy it wherever we need to. It allows you to figure out exactly where your posts are going to be and get them associated on the plan in your design, so you can figure out where flume's got to go, where your grading's got to go. Now, this isn't there to help establish length of need. It's there to, once you establish your length of need, to figure out in a realistic fashion where these eats are going to end up instead of just guessing 50 feet, 100 feet, or whatever. This will give you accurate post spacings. There's also the intersection blocks, and that's another palette here. And these intersection blocks are based on the standard detail drawings again, and they're just all of the different types of blocks that are available, or the intersections that are available in the SDDs are available here, and they're dynamic again. So if we're on a tangent section, I'm going to click on it and it'll load. I'm going to set my rotation so it's parallel or associated with this roadway here. There we go, and I can drop it in. Now we're anchored on the edge of traveled way, so I'm gonna, and again, this is a dynamic block. You can adjust the angles. I believe if you go into the properties, you can adjust the radius of the different curb and gutter. You can adjust the lane widths, the width of the shoulder or the turn lane, things like that. And then the design mode or graphics mode. If you only want to see the graphics, you can. If you want to be in design mode, you can turn that on. So it's very helpful for establishing basic geometry of an intersection based on the standard detail drawings. The rural driveway blocks are going to be very similar in that it allows you to establish 3D or 2D geometry of the rural driveways. Another cool tool that's out there is, we use these blocks to establish intersections. But now, how do we get that information usable in our design and intersection corridors and things like that? And one tool that we have is a tool that creates alignments from the blocks. So if I go to the alignment drop down and go to create alignments from BG block or create alignments from intersection block, self-explanatory. The first one's going to create alignments based on the beam guard block, and same thing, create alignments from the intersection block. So I got the intersection on the screen, so I'm going to click on it and select the WisDOT intersection block we want and select the main road alignment. And I don't have a side road alignment. I don't know if it'll run. Probably didn't, because I don't have that side road alignment. So let me quick create a side road alignment. So now that I have a side road alignment, I can rerun it. So good practice that you are seeing this, because you need to have a side road alignment and mainline alignment for the intersection block. So I'm going to run it again. We'll select the block. We'll select the main road alignment and the side road alignment. And this says process complete. And then it's going to create a folder in the tool space prospector under alignments and miscellaneous alignments. Created a folder for that intersection block. So we created a bunch of alignments based on the naming conventions in the FDM. So mainline roadway, side roadway, what side of the intersection it's on, and the type of alignment, curb and gutter, etc. So if I go over here and actually delete that block, now we have alignments left over. Another good thing is just to hide that block, put it on a layer and freeze that layer so those blocks go away if you don't want to see them, and then thaw that layer once you want to bring it back. The beam guard, create alignments from beam guard block is going to be very similar. You're going to select alignment, select your block, it's going to create a folder with a bunch of alignments in it. Okay, so a little shift now. I jumped into another DWG, kind of the same project, but a little more advanced in the design process. And what I have here is most of my roadway geometry has kind of been developed. I've got set up corridor for the main line and side road. And what my next step now is to work on establishing the curb returns. And to do that, we developed an alignment style that allows us to kind of work our way through building the curb return alignments. Now this is if you aren't going to be using the beam or the intersection block, dynamic blocks to build your intersections, and something complicated like this, you can't really use that. You can, but it might be just better to build your intersection by manually using alignments, offset alignments, circles, and stuff like that. But in this case, what I want to do is create an offset alignment that represents the location or the offset from the reference line to the curb and gutter flange at the tangent points. So in this case, I know that my offset from the edge of travel of the way here is 10 feet. So what I want to do is create an offset alignment that represents that 10 feet. So I'm gonna actually freeze my corridor because I don't want to see that right now. I'll do this one too, and I got a bunch of setup corridors in there, so I got rid of most of them just to hide them. And now I want to create an offset alignment based off of this edge of travel of the way. You could do center line as well. So I'm going to grab this alignment, create offset alignment, and what I'm going to name it is just do 8-right-construction line, just so I know that it's kind of a construction or a drafting line type object. And I'm going to just adjust my limits so I don't want to go too far, but on the left side I want none, on the right hand side I want 1, and I want that to be 10 feet or the distance from my edge of travel of the way to the curb and gutter flange. I'm going to set my alignment style to ALI construction line, and OK. And there we go. It's established. Here's that construction line, and all it is a gray shade dashed alignment. Not really used for plans production, it's just a drafting line. I'm going to do the same thing on the side road as well, and we'll do it off the center line this time. And local collade, we'll insert a side. And OK. And on the left hand side, I don't really know what this is going to be, so I'm just going to adjust it later on. I'll set them at 15 for now and go from there. So that's all good. Almost got them. I'm pretty close actually. I'll leave it at 15. I think that's 3 feet. All right, so we have basically alignments that represent the flange offset from the center line and of the respective roadways. Now what I can do is actually drape those on my setup surfaces, because I know that those setup surfaces are going to establish kind of the pavement surface, and I want my flanges to tie in at the ends. So what I can do now is use a new tool, and actually I can show that off right now. This is a new tool that's out there. It's called, in the profile area, Create Surface Profiles. And what this is a batch surface profile creation tool. So I can go and select all my alignments that I want to create surface profiles from. And then I can choose which surface I want. I want set up top. And this profile style, you can set that. In this case, we do have a profile construction line as well. Label set as well. This really only applies, especially the label set only applies to profile views that are already created. If you have to create a new profile view later, you'll have to set the label set later as well. We'll click add, and now we have the profiles in queue to be ready to be created. Now I can create ones on the existing surface as well. This one I want to be profile existing if I really wanted to. And we click OK, and it's going to go through and batch create those surface profiles. If I go look in tool space now and check out those alignments, offset alignments, look at this construction line, we can look at profiles, and now we have the left and the right construction line alignments. Now this guy here is a leftover. This is the offset profile that was built when I had created the offset alignments. There was an offset profile already built. Gotta be careful with that, because sometimes they get made and don't really know what they are. I'm not going to use them. So I've got those profiles made. So that was a good way to be able to show and demonstrate the surface profile tool, because that is very useful for creating lots of surface profiles. Thinking intersection work, roundabout work, you're always doing kind of surface profiles on different setup surfaces and things like that. So that's where it becomes useful. Now I'm going to utilize the connected alignment tool in Civil 3D to create a curb return alignment. We have our offset that we're referencing These offset alignments that are represented here are draped on our corridor top surface, our setup corridor surfaces. So where they're draped on surfaces that represent what the pavement's going to look like, where we want the curb returns to tie in. So now we're ready to build our curb return alignments. You can go to the Create Design panel, Alignment, drop down and scroll down to Create Connected Alignment. And we always want to work in a counterclockwise direction with the respect to the alignment stationing for the curb return alignment. So in this quadrant, I'm working in the clockwise direction. Working in a clockwise direction. So I'm going to select this alignment first and this alignment next, because I want the station for the curb return alignment start on the side road and go to the main line. I want the location of the connected alignment to be in the middle, out in this area. Now it's previewing kind of where it's going to go. Station this way, the radius is there, and then station out. That's good, so I'm going to hit enter to accept it. Now I'm going to name the connected alignment what I want it to be. So in this case, I want it to be the name of our standard curb return alignments. So intersection and 8, clade, and we'll call this one the southeast quadrant. And we'll name it CG for curb and gutter or flange alignment. Now this is matching the standardized naming conventions per the FDM. I can set my alignment style to roadway, curb and gutter, flange, and no label set. Design criteria does not need to be set. We're not setting any super elevation parameters. We want to change to curve type to circular fillet and specify the curb radius. I think this probably could be 60 feet maybe. I don't know off the top of my head. We can verify that later. And the offset in and out, we'll set that to 0 on both of them. I believe the template should have that set. This drawing might be older, it doesn't have that for some reason. And the connection overlap in and out, we'll set that to 10 feet if it's not already set there. Because that's how much past the radius point or how much past the tangency point that the alignment's going to extend. We'll set that to 10 feet. We can always change that later on. Now, if our offset alignments we're basing it off of, or the reference alignments that the connected alignment is going to be based off of, in this case, the construction alignments here have profiles, which we already created earlier. It'll allow us to create a connected profile. What that's going to do is going to look at the two profiles of the reference alignments and connect them together. So we'll create a profile from the connected alignment. We'll choose the connection in. This is set up top on the side road. I'm going to deselect cross slope, and on the out portion on the main line, I'm going to do the set up top as well. Deselect cross slope because we want it to follow the profile of the roadway. And we'll name the profile proposed because this will end up being your proposed profile. Profile curve type, we can leave that at 5 because we can adjust that later on. And there we go. We have our connected alignment. Looks like I probably need to adjust the radius a touch. So I can go into the connection parameters and change it to probably 55. I would venture to guess maybe 50. I'm just looking at the radius point compared to my geometry I had before. That looks about right. Okay. So we have our dynamic connection made. Now if you adjust anything, let's say I want to adjust this offset alignment, let's say I want to adjust the width, that alignment goes with it, however we want it. So you adjust your side road, the alignment and profile will automatically adjust with it, which is nice. With that, that's where that connected alignment really comes in handy. And believe me or not, it also has a profile. So I can select our curb return alignment here and run through the process quick. Just create a profile view. We can see it's got a design profile that is dynamic to the locations of the tie-ins on the ends and the other side road and mainline profiles. And you can I make adjustments to that from a profile as well as needed. One last bit here in the alignments portion is the create curb offsets. So we established the flag line, but now if you've ever done any urban design or any intersection design and you want to have alignments representing the face and the back of curb and gutter, it's kind of cumbersome to go through one click at a time and select the alignments one at a time. So we'll go to the WisDOT Design tab, Design drop-down, Alignment, Create Curb Offsets, and this tool will allow us to create automatic offsets on the curb and gutter for the face and the back. So I'm going to specify the offset to the face is 2 feet, and the total offset from the flag line to the back is going to be 3 feet in this rural curb and gutter, 36-inch curb and gutter. I'm going to select my baseline alignment that I want and the range that I want. So if I can do the entire alignment if I want, or I can do a specified range. In this case, I'm going to specify the start of the radius and the end of the radius. And then I'm going to pick the side. Now if I had more alignments, I can go around and select more alignments. Let's just maybe try and crash it. Select this edge of traveled way. We can do the entire range. Maybe I'll just do this little portion here. I'll pick the side, and there we go. It created those alignments as well. And it remembers your offsets, so if you have 4 alignments in this intersection, you just go around and click them, which is nice. So that's the Create Curb Offsets tool. Very, very useful for doing curb and gutter and establishing alignments for the back and face alignments. All right, so I jumped into a fresh DWG because I want to talk about some corridor stuff now. And the first one I want to discuss is when data referencing alignments. This isn't really corridor related, but you're gonna need it when you get into a corridor, creating a corridor drawing or a pavement drawing, or things like that. And what I want to do is actually data reference a bunch of alignments in. So I'm going to go into here. I'm going to just go grab all my proposed alignments, drag and drop them in. You can zoom extents to see them coming in as we get them. And then I'm going to go in my offset alignments. I'm just going to grab all of my ones except my miscellaneous and not my construction lines, but everything else, curb and gutter, back, EPS, ETW, drag and drop those guys in. I'm not going to set any styles or anything like that. And you can see what a mess that really makes. I'm going to grab a few more, just see at the last bit. I got curb return alignments here, and drag and drop those guys in here. Now this is where this tool comes in handy. From the WisDOT Design tab, Alignment dropdown, Assign Alignment Styles. Now this is a tool that, based on an CSV, I mentioned CSVs earlier, but based on a CSV is going to assign the alignment style and label set based on the name of the alignment. So if I go and look at the CSV, it's located in C, Program Data, Autodesk Application Plugins, and then the bundle, Content, ENUS, Assign ALI Style CSV. I would recommend if you want to make a copy of it, don't modify this one, or modify it, don't modify this one, modify the one copy to your project. But basically, there's some keywords in the name that lead to a certain style. So for instance, CG turns into roadway curb and gutter flange. EPS turns into shoulder paved. So if I follow those naming conventions, and this is based off of what's in the FDM, if I follow those naming conventions, theoretically, when I go and run this tool, everything should be stylized correctly. So I'm just going to apply default. You can see there's also a way to view that default, that CSV I was just in here. And then you can actually browse to the current folder of the DWG or to your last selection. So it remembers everything from that aspect. I'm just going to do apply default because I just want to use the default file. And I want to assign to every alignment in here. So select all, and there we go. We can see it automatically assigns the correct alignment style based on the naming convention. This one's got an EPS in it. This one's got an EGS, for instance. And that just plays in the fact that following the naming conventions that you set for your project, if you want to follow what's in the FDM, it just makes these tools a lot more simpler and work a lot better. And thus makes your workflow much more efficient. All right, let's jump into some simple corridor workflows that you can utilize. I'm going to go to the WisDOT subassemblies palette and just jump in and use some generic assemblies that we have here. And let's do rural full section. We'll drop that in like so. I'm also going to grab the curb and gutter one as well. So beam guard, not curb and gutter, beam guard. We'll use the beam guard subassembly as well. Drop that one in there. Just for fun. I'm going to create a corridor quick. Here I've got my centerline profile established. And so I'm going to create a corridor. And we're just going to do this corridor -8. Actually, I'm just going to name it 8. Alignment is 8, profiles 8, assembly is going to be rural full section, and target services exist. And I'm going to set my station range from somewhere in here to somewhere up here. And click OK. I didn't set any targets. The only target that was set was the existing grounds, existing surface target. So it does a little bit of targeting. We'll get to the targeting in a little bit. The next thing I want to show off is the control profile editor. And what the control profile editor does, the control profile editor was developed by WisDOT to quickly create profiles without the need for a profile view. Basically, it's a tabular editor of profiles, and when using these profiles, the subassemblies we have are able to read these profiles, such as we set an elevation of 0.25, and the subassembly will read that elevation and output a 4:1 slope. So the control profile editor is a way to allow us to manipulate slopes of different subassemblies and create slope transitions in any of our WisDOT subassemblies. And so I'm going to jump into that. So WisDOT design, profile, control profile editor. And what we see here first is the create tab. And basically, if you're working on, like in this case, I'm working on Highway 8, it's the main roadway. I want to assign the profiles to the main baseline alignment. In this case is going to be 8. And so you can go through and create individual profiles. In this case, I can name something like clear zone slope. But what I would recommend, especially if you're doing a lot of grading slopes and using the WisDOT standard subassemblies, I would use the create multiple version. You can create multiple profiles based on a default CSV, or if you create your own CSV, you can do from file. I'm gonna click on view default so we can just view that default CSV for a minute. And what actually we can do is we can see that there's the X is for create. So if you wanted to create that profile, we can have an X in there. If you don't want it created, we can delete those X's. And then it says, here's a profile suffix. This is what it's going to be named, and then what the default value is, and then a description of the profile. So I'm just going to leave the defaults. Don't save it. If you want to make a copy of it, you can save a copy to your Civil 3D project folder. So I'm going to create multiple profiles from the default and click create. And this is verifying this is what was in the CSV. This is what we're going to be creating. And you can deselect if you wanted to as well here. Hit continue, and now it's going through and creating control profiles for each one of those individual inputs. Now I can go to the Edit tab and navigate to 8, and now I can see all these individual profiles. You can see there's profiles here for the ditch fill switch, the connecting slope, the berm width, the berm slope, final slope, recoverable forest slope, shoulder forest slope. And these are all different targetable aspects of especially the daylight profile controlled subassembly that is in the rural roadway full section assembly here. You can create a profile view from it, and if you wanted to, but a lot of work can be done directly here in the control profile editor. I'm going to jump down to final slope, and this control profile editor is tabular, of course, and now we can actually edit the profile or add different transition points. So let's say I want at this station to stop being 3 to 1, so I'm going to set this point 3333, and I'm going to add that value. And then let's say at station 126 plus 0.1.55, I want it to be 4 to 1, so 0.25. We'll add that. And then you can also add more. So let's say at station down here, we want that to be 4 to 1. We'll add it. And then we want to transition it somewhere in here to 3 to 1. So we're just adding different values and transitions. So up to this point is 3 to 1, and then the transition to 4 to 1, 4 to 1, 4 to 1, transitions back to 3 to 1. Hit close. Now we need to assign that target in the assembly or the corridor, and what we can actually do is use another tool that WisDOT has developed. It kind of is a mass targeting exercise, and this one's a little more complex because you have a CSV and you have to make sure a lot of naming conventions are followed. But if you follow the naming conventions, it can be very useful. So I'm going to go to the corridor, assign corridor targets. I'm going to set the corridor, I'm going to set the baseline, I'm going to set the region I want. If I want to, I can zoom to that region. And then I'm going to specify what targets I want to assign. So there's predefined CSVs sitting in the C, WisDOT, STND, Civil 3D project folder, components, assemblies, and there's 4 CSVs sitting there. And I'm just going to open one just to view. You can also open it directly from the tool. Again, it's the CSV. There's a name column, how far to search for it, what subassembly it's going to be assigning it to, and kind of the target parameter, so forth. So basically it's looking for an object, and then it's going to assign that object to the subassembly and which parameter it's targeting. Does it for both offset and elevation targets. So I'm going to select my full section assembly, navigate to WisDOT STND. We'll go grab the default. Again, I would recommend you copying it over to your project. And then I'm going to rebuild the corridor and hit OK. The first section, open template, just going to select which template you want to open, and then to actually assign the targets, you got to go select which CSV you want and close. And now you can see that we have some nice slope intercepts. We can see our targets for the ETW and everything are set correctly. If I go into the corridor properties and edit the targets for that region, now look at, let's say, the daylight profile control left, and all of my berm, here's my ditch fill switch is assigned, connecting slope, ditch back slope, all of those are assigned. And then same with the shoulder generics, the lanes, or that's forest slope width, paved width, all that stuff is assigned. So all those different targets get assigned just with a quick couple clicks. Instead of having to go through and select each one and make sure you get them all correctly selected, you can pre-assign all the things as long as your naming conventions are standardized and consistent. Now, once we have our corridor developed, we can create corridor surfaces. Now, there is a tool within Civil 3D to create corridor surfaces, but we tried to make it a little bit better. So I'm going to go to the corridor dropdown, create corridor surfaces. And again, there's a default CSV file. We can view it. And basically, it is taking, if you want to create which corridor surface you want to create, and then this is the name of the surface and the style that's going to be assigned. And then we have all of the different feature line codes or point codes that are in the subassemblies that match what we want for that surface. So you can go in here, create your own, edit it, add your own point codes if you need to, but it just simplifies and makes it faster to create your corridor surfaces. I'm going to apply default, and we'll select the corridor I want to build it from, and yes, I want to rebuild the corridor, and there we go. We have our corridor surfaces created, but now I need to get them shrink wrapped and make them applicable and sized to the appropriate areas for that corridor surface definition. Again, there's corridor surface boundary tools inside of the corridor properties, but we built another tool that shrink wraps the corridor surfaces to the definitions that are built into that corridor surface. So I click on the corridor drop-down, shrink wrap corridor surface. And we'll start with corridor datum, and we'll just say select by surface definition. And basically what it's going to go do, the surface definition is built from these 3 point codes. It's going to go through and determine the boundaries of those point codes and build a boundary for that corridor surface based on the inputs of the objects going into that surface. So I'm going to click OK. There we go. Now we can do the same thing with top. Select by surface definition. OK. There we go. So our datum surface is right here. Only as big as the definition of the objects going into it, and same with the top surface, only as big as the definition of that surface. Again, all these tools, all documented on the Civil 3D knowledge base. Most of our workflows incorporate them already, but if you haven't seen them, they're there and easily accessible. That's about all the demo that I really wanted to show today. And some of the other ones I wanted just to mention, there's a bunch of surface tools that are new and on the Civil 3D knowledge base, such as add corridor entity as break line. You can create a crop surface, create a wall surface. There's pipe network tools for moving pipe ends, swapping part styles, checking pipe separation at structures. And then there's a bunch of visibility checks from profile site distance to intersection site distance. And then finally, there's a bunch of output tools for quantity takeoff and creating quantities for plan sets and exporting contractor data or construction data. It's all there. Everything's documented on a Civil 3D knowledge base. Again, if you need help getting into using the tools, you can just highlight over something, hit F1, and it'll take you directly to the help document for that tool. And again, most of the Civil 3D knowledge base tools are documented, and the workflows, and incorporate most of the tools that are on the ribbons. Again, my name is Mitch Lavin from the Wisconsin DOT Methods Development Unit. Don't hesitate to email me. Let me get my contact info up here. There we go. Now don't hesitate to email me or contact support.cae@dot.wi.gov, support.cae.dot.wi.gov. And if you have any questions regarding the customization package or if any problems with it. And I hope you enjoyed this presentation today, and have a good one.